Hello, welcome to the EPG Pathshala program in Linguistics. I am Pramod Pandey, Center for Linguistics, Jawaharlal Nehru University. I am the principal investigator of this project. We are now going to listen to the discussion of a module from the paper Introduction to Linguistics. The coordinator of the course is Professor Amrita Valli, professor retired from English and Foreign Languages, University Hyderabad. The title of the module is Language and its Interfaces, Semantics, Logic, and Concepts.
Module Language and its Interfaces, Semantics, Logic, and Concepts. Objectives: to introduce the model of knowledge of meaning as knowledge of truth conditions and compositional semantics using semantic rules and function application. Outline: Introduction. What is meaning? Meaning as dictionary definition. Meaning as concepts. Meaning as truth conditions. Predication and saturation. Modifiers. Quantifiers. Negative polarity items. Introduction. Semantics is the subfield of linguistics that studies the meaning of a sentence or utterance, how meaning is constructed, and what the building blocks are, and what the rules and restrictions are on the possible combinations of the basic units of meaning. It uses a lot of tools that come from logic and mathematics. Hence, it is also called formal semantics, as it uses the formalism of logical formulae. This formalization allows the constructions of very precise interpretation for sentences, but it also makes it difficult to follow a semantic argument without being technically trained in the abstract logical framework. What is meaning? Meaning as dictionary definition. If the meaning of a sentence or a word is given in terms of more words or sentences that paraphrase or define what the sentence or word means, meaning holism, as in, for example, a dictionary entry, meaning eventually becomes circular, using more pieces of language to establish the meaning of one piece of language. Meaning as concepts. If meanings aren't more words, may they be concepts or ideas in the mind? For example, say the meaning of the word monkey is the concept monkey that a person forms and associates with the word. Then every word has a concept associated with it. But what is the concept associated with words like how, and, if, etc.? A big problem for the meaning as ideas or concepts theory is posed in the twin earth thought experimentals by Putnam. Also, how do we understand the concept monkey? The best way to express this is perhaps to say that when we have this concept, we can identify all the animals that fulfill this particular property. Meaning as truth conditions. But if we are going to explain the concept monkey in terms of all the animals which it encompasses, why not link the meaning of the word monkey directly to the set of animals? Then, if word meaning is language external and there is a mind external reality out there in the world to which a word can or cannot apply, then the meaning of a sentence is the conditions in the world under which this sentence is true. The knowledge of meaning is the knowledge of the conditions in which a sentence or a word is true. This is called as the truth conditional semantics or model theoretic semantics, and the central idea of this theory is that knowing the meaning of a sentence is knowing its truth conditions. This idea is common to other variants of semantic theory such as possible word semantics and situation semantics. Synonymy, entailment, and contradiction. Meaning as truth conditions also gives us a handle on some intuitive semantic concepts like synonymy, entailment, and contradiction. Two sentences are synonymous if they have the same truth conditions, the same set of possible worlds in which they are true. Two sentences are contrary if the set of conditions or worlds in which one is true are completely disjoint from the set of conditions or worlds in which the other is true. A sentence entails another sentence if the set of worlds in which P is true is completely contained in the set of worlds in which Q is true. The tool of possible worlds becomes very useful in understanding modality and the semantics of worlds like must, can, may, and necessary. Interrogatives and imperatives. If the meaning of a sentence is its truth conditions, what are the truth conditions of an interrogative sentence? Like, what did you eat? The meaning of a question is the set of propositions that are possible answers to it. Now that we know that the meaning of a sentence is its truth conditions, how do we arrive at the meaning of a sentence from the meaning of its constituent words? This is the central goal and major preoccupation of formal semantics. In the rest of this module, we will see some of the basic ways how meaning is put together from pieces. Predicates and saturation. Let us start with a two-word sentence like Kumbhakarna snores. What is the meaning of snores? We can get the meaning of snores by subtraction, removing Kumbhakarna from the proposition. We already know that the meaning of the proposition is the set of possible worlds in which Kumbhakarna snores. The meaning of snores would then be an incomplete proposition with the subject missing. Technically, a predicate like snores is an unsaturated proposition, also called a property. The relation between a predicate and its subject is called predication. The phrase that saturates a predicate is the argument. Properties are formally modeled using functions and a system called the lambda calculus. A function is a mathematical formula which takes an input and delivers an output. The input is known as the argument and the output is known as the value. The set of possible inputs for the function is its domain and the set of possible outputs is its range. The lambda calculus is a compact and a nice way of expressing functions. For example, the property denoted by snores is represented in the lambda calculus thus as function.x snores. A single letter called the variable indicates the place where the proposition is unsaturated. The lambda and the associated variable here, x, announce that this formula indicates a function and that the variable is the argument of the function. The property is fat and the property is loyal are represented by the formulas as shown. Function.x is fat, function.x is loyal. Modifiers. Intersective and subsective modifiers. Another basic semantic relation besides predicate saturation is that of modification. In the sentence, Kumbhakarna is a loyal Rakshasa, the phrase loyal Rakshasa is a complex predicate formed from the two simpler predicates loyal and Rakshasa that we saw earlier. How do the two properties come together to form another predicate? Neither one can saturate the other. A completely new process of semantic combination called predicate modification is at work here. The precise technical implementation of this rule is beyond the scope of this module, but it derives the truth conditions that Kumbhakarna is a loyal Rakshasa if and only if Kumbhakarna is loyal and Kumbhakarna is a Rakshasa, basically an intersection of the two properties loyal and Rakshasa. But not all modification is intersective. For example, the truth conditions for Kumbhakarna is a short Rakshasa are not the same as Kumbhakarna is short and Kumbhakarna is a Rakshasa. If Kumbhakarna is 10 feet tall and the average height for Rakshasas is 15 feet, he is a short Rakshasa. But Kumbhakarna is tall by human standards. So what counts as short depends on the context or the comparison class. When short is combined with the Rakshasa, the comparison is restricted to only other Rakshasas. In intersective modification, on the other hand, the comparison is with any relevant set and not just Rakshasas, as in the sentence Kumbhakarna is short. These kind of modifiers are called subsective or vague and are treated not as simple predicates but as higher order predicates which can only be saturated by another predicate. By itself, the meaning of these predicates can't function as the main predicates of a sentence, as it can only be saturated by a property, not by an individual or entity. So, short takes a property P and then means shorter than the average P. So, short Rakshasa is a function that takes an entity X and returns true if and only if X is a Rakshasa and X is below the average height for a Rakshasa. Relative clauses can function as modifiers just like intersective adjectives. For example, Kumbhakarna is a Rakshasa that Rama killed has the same derivation as an adjective plus noun combination, with the two predicates in this case being Rakshasa and that Ram killed. Adverbs. Another set of modifiers are adverbs. In a sentence like Kumbhakarna snored loudly, the meaning contributed by loudly is that Kumbhakarna's snore was loud. Kumbhakarna's snore is the event described by the verb snore. Many linguists now think that the meaning of a verb like snore or kill in terms of one place or two place predicates is not enough, and more decomposition of the meaning into thematic roles like agent, patient, and an event of snoring or killing are warranted. So, in terms of events, the meaning of our sentence is that there was an event of snoring, Kumbhakarna is its agent, and it was a loud event. The suffix li attaches to the adjective loud, which modifies nouns and turns it into an adverb which modifies events. The composition is exactly parallel to the intersective adjective case we saw above. There was an event of snoring and the event was loud. Manner adverbs like loudly and locatives and temporals like in the bed and last night, etc., which describe the place and time of an event, are composed this way. But not all adverbs can be treated as intersective. For example, in Kumbhakarna snored intentionally, the event of snoring is not merely intentional. It is intentional only on Kumbhakarna's part, not on anybody else's. For example, if Ravana intended for Kumbhakarna to snore, but Kumbhakarna himself didn't, this sentence can't be true. For these adverbs, we need the more complex perspective on adjectives as higher order predicates. Intentionally is saturated by a property P, and together they form a complex property which describes an individual X if X did P intentionally. Here, intentionally combines with the predicate snored, and this complex property describes an individual who snored intentionally. Quantifiers. We have seen noun phrases which refer to a set of entities like monkey and those that refer to an individual like Kumbhakarna. But not all noun phrases are referential. For example, nobody. Phrases like every Rakshasa, many Rakshasas, some Rakshasa and no Rakshasa are called quantifiers as they express the quantity of some noun. A quantifier has a determiner like every, some, many and no, and a restriction, a noun phrase like Rakshasas. To understand the meaning of quantifiers, let's take a sentence like every Rakshasa snores. We already know two modes of semantic composition, predicate saturation and a predicate modification. We also know that snores is a property and Rakshasa is a property. Compositionality tells us that the meaning of every combines with that of Rakshasa, and this then combines with the meaning of snores based on the syntactic structure every Rakshasa snores. So either every Rakshasa must saturate snores or vice versa. But only individuals can saturate a predicate, and every Rakshasa does not refer to an individual. So it must be that the meaning of snores saturates that of every Rakshasa. That means the quantifier is saturated by a property, giving rise to a complete proposition. In other words, the quantifier is a predicate that takes a predicate and returns a proposition, reversing the usual mechanism of saturation. A quantifier is a second order property, a property of properties. Here, every Rakshasa tells us that the property it combines with describes all of the Rakshasas. The determiner every combines with a noun such that it describes a property P if P is true of all the nouns. N refers to noun here. N is an argument of every and saturates the incomplete quantifier represented by the determiner, which then is saturated by the property P. An extension of this intuition beyond quantifiers to all noun phrases, including names for the sake of uniform semantics, is called generalized quantifier theory. It also allows for a conjunction of a quantifier and a referring noun phrase in a sentence like Kumbhakarna and every monkey snores, because only two phrases of the same syntactic and semantic type can be joined. Negative polarity items. Negative polarity items, or NPI, illustrate a deep logical property that natural language is sensitive to and some crucial evidence for linguistic theory. In understanding NPIs, the two main questions are: what kind of sentences or environments allow or license NPIs, and what do they have in common? Why do NPIs require a licensor of this kind, and what is it about NPIs that needs these environments? NPIs have been described to like to live in the shade of negation. For example, ever and any occur in sentences like Kumbhakarna won't ever wake up and Kumbhakarna doesn't have any friends. But not in sentences like Kumbhakarna will ever wake up and Kumbhakarna have any friends. Therefore, NPIs occur mostly in sentences with negation. But NPIs can also occur in some not obviously negative contexts like questions, conditionals, and some quantifiers. For example, will Kumbhakarna ever wake up? Does Kumbhakarna have any friends? And some Rakshasa that has ever tried to wake Kumbhakarna has failed. Or some Rakshasa that has any friends does not snore. These are all ungrammatical sentences with some. Klima, 1964, one of the earliest proponents of a theory of NPIs, proposed that they must be in construction with a trigger that is either overtly negation or an effective element. This did not have much explanatory power besides incorporating the descriptive generalization into a syntactic licensing analysis. Fauconnier and Ladouceur approached the matter from a semantic angle and noted that NPI licensing context shared a subtle and deep logical property, that is, downward entailment. To understand downward entailment, we take a word which expresses a property and compare it with other words that expresses a subproperty, hyponym, or a superproperty, hypernym. For example, carrot expresses a subproperty of vegetable. Food is a superproperty of vegetable. A simple, non-negative, non-quantified, declarative sentence allows inferences from properties to superproperties. This is called upward entailment. Kumbhakarna ate a carrot entails Kumbhakarna ate a vegetable. The logical feature of not, the most basic of NPI licenses, is that it reverses this inference pattern, creating entailments from properties to subproperties, and this is called as downward entailment or downward monotone. For example, Kumbhakarna did not eat a vegetable entails Kumbhakarna did not eat a carrot. With respect to the property of downward entailment, the restrictions and predicates of these quantifiers show the following pattern. NPI is acceptable inside the restriction of every, but not in its predicate. For example, every creature snores entails every Rakshasa snores. NPI is not acceptable inside the predicate of every. For example, every Rakshasa snores does not entail every Rakshasa snores loudly. NPI is bad in both cases of some. For example, in the case of restriction, likewise, some creature snores does not entail some Rakshasa snores. And in the case of predicate, like some Rakshasa snores does not entail some Rakshasa snores loudly. NPI is acceptable in both the restriction and predicate of no. For example, no creature snores entails no Rakshasa snores, and no Rakshasa snores entails no Rakshasa snores loudly. If we summarize the distribution of NPI licensing and the distribution of downward entailment with the two properties that saturate a determiner, we get the following examples. It is clear that all the environments that are downward entailing are precisely the context where NPIs are licensed, thus providing good support for the semantic analysis of Leduso and Fauconnier that it is the logical property which is necessary for an NPI's survival.
Summary. So you have seen how the author has tried to introduce the model of knowledge of meaning as knowledge of truth conditions and compositional semantics using semantic rules and function application. Semantics is the subfield of linguistics that studies the meaning of a sentence or utterance, how meaning is constructed, what the building blocks are, and what the rules and restrictions are on the possible combination of the basic units of meaning. It uses a lot of tools that come from logic and mathematics. Hence, it is also called formal semantics, as it uses the formalism of logical formulae. The formalization allows the constructions of very precise interpretations for sentences, but it also makes it difficult to follow a semantic argument without being technically trained in the abstract logical framework. We have discussed in great detail topics such as the nature of meaning, what meaning is as defined in the dictionary, meaning as concepts, meaning as truth conditions, predication and saturation, the modifiers, quantifiers and negative polarity items in relation to meaning. We hope that you will have had occasion to go through the exercises and do them well. It's also necessary that you familiarize yourself with some basic notions of formal logic that will help you to understand the module better. Thank you.